Welcome to our new lesson. This is about inequalities involving quadratic functions 3.5 from our book. So let's look at our agenda. We will be checking graphical methods and algebraical solutions also we'll look at for inequalities. We have two examples with alternative methods also. Then we have in-class practice and practice homework. So these are our setup for our today's class. Let's look at, of course, we'll discuss the theory also. First of all, we'll discuss theory related to this chapter. So first of all, what is quadratic inequalities? Quadratic inequalities is just simply our regular quadratic function. You can see this is our regular quadratic function, and then inequality sign. This greater than, less than, they are inequality sign because they actually tells us this thing is greater or this thing is less. So not equal. Inequality means not equal. What kind of that kind of thing. So in some function, if they say that ax squared plus bx plus c is greater than 0 and a is not equal to 0. Why a is not equal to 0 is written here. The reason is if a becomes 0, then it becomes a non-quadratic function. So first of all, our functions needs to be quadratic because we are discussing the quadratic inequalities. So a is not equal to 0. Why it is this? Because it makes our function, it keeps our function quadratic. So when they says that ax squared plus bx plus c is greater than 0, that means they are telling us where in this function our this ax squared plus bx plus c, this value is more than 0. Okay, this kind of thing. So in other words, above x-axis, where the function is above x-axis. Okay, this is what it means. And to solve it, we consider the graph of function. First of all, we consider that this equals to 0, then we try to find out the x-intercepts, and then we look at the shape of the graph. Let me show you. So suppose if we take two lines, of course similar kind of thing we have examples of course. So then if I take something like this, we can draw open up or open down any kinds of graph, and let's draw some open down graph. Suppose we have a graph like this, and we can assign some value here. So according to this question, where the graph ax squared plus bx plus c is more than 0, you will notice that the more than 0 is this part of the graph. That means this part of the graph is the value of this graph, this part here is more than 0. And you will see that, you will notice that this value means y value. Each of this point you can assign point everywhere, and you will see the y value is what? That is called the value. And this part will be the only positive. You can say, sir, oh, this is negative. This is negative. Yes, this is negative, but y value is positive here. Y value is positive here. Any point here you can see. Suppose, just for instance, let's say suppose this point is minus 1 comma 2. Suppose, and then this is the value of the function. This is the value of the function. This is not the value of the function. This is where is it? Where is this value? A minus 1 actually it tells us that. So this 2 is the value of the function. And ax squared plus bx plus c is greater than 0. It means where the value is more than 0. Now you can say, sir, okay, this is open down graph, so now we know that this part is more than 0. So what about open up graph? We can draw open up graph also similarly, likewise, and we have to look at like where the function is more than 0. And we actually have similar that kind of thing in the coming slides. And suppose if you are interested, you can say, sir, okay, let's look at where it is less than 0. So less than 0 is this part, this part. Because graph will continue forever, less than 0 is this part, and it will continue because the graph will continue forever in this direction, in the both direction. Now you can say, sir, what about this? Is this point is less than 0 or greater than 0? Now there our graph do not belongs here. The graph do not belong here. Graph is here. Okay, graph is here. So that means from this point to this point, from this point to this point, our graph is more than 0. This is very important. Look at this carefully. From this point to this point, we can give some name here for our just let's say suppose this is our -1. Suppose this is -2, and let's say this is we can keep it same. Okay, we can keep it same. 1 2, but it's not necessary. Suppose graph can shift this way or that way, you already know that. So just for this question, for this example here, where it is greater than 0, we will say that from -2 to +2, from -2 up to +2, our for this function our graph is greater than, this part is greater than 0. This part of the graph is greater than 0. This whole part graph is greater than 0. And now you can ask that question that I was indicating, where it is less than 0, then you have to say that any value, suppose from -infinity up to -2, here less than 0, and from +2 up to +infinity, the value is less than 0. We can say that because this is very intuitive also. If this part is from -2 to 2, if it is this is more than 0, that means the other part has to be less than 0. That's why we are saying that this guy here is, or this part here is more than 0, because our graph actually continues forever. Our quadratic function graph, this is another rule, quadratic function graph continues forever in the both of the both positive x and negative x direction. So this is how we decide about this. And look at this one thing, they are saying that strict inequality, if the inequality is not strict or this is strict, so what does it mean? This means strict inequalities. This means strict inequality. And if they give greater or equal to also, that means this is not strict inequality. For the same math, if the question is given like this, if the question is given like this, for this same example, then the answer will be from -2 to 2, because this is non-strict, not strict. This is not strict means simply the value is included. That means that. And if it is just greater than, it means the value has to be greater. So you see at -2 the value of the function is 0, but our question is where it is more than 0. So more than 0 has to be somewhere up, somewhere somewhere here, not here. It is -2. At -2 we know that it is 0 for this one. Now if you are thinking that, sir, how do we know that this is the graph of this function? This is not the graph of this function, this is just an example. Okay, and we can actually bring any example and all of them will be true for that. So what is strict inequality? Strict inequality means only greater than or less than. And what is not strict? Not strict means greater or equal to, less or equal to. They are not strict inequality. So this is the theory for this kind of questions, and you will see if you understand that theory, actually the other maths becomes easier for us. So this is the math, and this math is taken from the book, of course. And look at this, you will see that this is also somewhat similar. Our question is this: x squared minus 4x minus 12, where it is less than 0. Okay, where our in our theory we discussed that it is greater, where it is greater, where it is less or equal to 0. suppose this graph is given, the graph is given, suppose the graph is given, then what will be your answer? What will be your answer? This is x squared minus 4x minus 12 less or equal to 0. This is the function, this is the graph. Now where is the solution? Where in these functions, where it is less than 0? You will notice that here it is more, right? Here it is more than 0, more than 0. You think about it. What could be? Of course the solution is actually written here, but suppose this side is not given. Suppose this side is not given. Just only this function and this is given. Then what will be the solution? Actually, in that case, solution is more easy. If this and this is given, solution is easy. And you will, of course, you will notice that the solution is actually this part. This part of the graph is less than 0. This is below 0. Below means x below x-axis. Where it is above x-axis, above x-axis is more than 0. Below x-axis is less than 0. So our question is less than 0. Less than 0 is this part. Okay, less than 0 is this part. That means from -2 to 6, we have our solution. That means from -2 to 6. And you see this is less or equal to, that's why we have to give the third bracket. And this is the set notation. And if you want to write interval notation, then our solution will be solution set x such that from -2 less or equal to x less or equal to 6. Both means the same thing. Both means the same thing. Now you may ask from where this graph came. That's why this is the solution from where the graph came. First of all, for drawing the graph, we have to think about where is our. You will not have to draw it. Okay, in your exam or in other cases, function and graph will be given. You will not have to draw it. But in some algebraic problem, you may need to find out the x-intercepts. So that is important also. How to find out x-intercept? Again, that is also easy. You think about our this function x squared minus 4x minus 12. This equals to 0. If this equal to 0, then factor it. We have learned how to factor quadratic function in our previous lesson. In some couple of our lesson actually, not in one. So first of all, one thing you notice that our y-intercept is 0. So y-intercept is 0, minus 12. So we have our y-intercept minus 12. Then our x-intercept, to find out the x-intercept, we write y equal to 0, or in this case we can just simply consider that this inequality equals to 0. This inequality means 0. Just simply we can write, instead of less or equal to, simply we write equals to. Just for solving it. Okay, just for solving it. So we consider that this equals to 0, and then we do the factoring. So two factors from here, x minus 6 and x plus 2. That means if it is x minus 6, plus 6 will be one x-intercept, and if it is x plus 2, minus 2 will be the another x-intercept. So we have y-intercept already we know, and x-intercept is minus 2, another x-intercept is plus 2. Actually, from this line, if you solve up to here, then actually you know the solution, because you know that your graph will be graph is x squared. So you see roughly how you can draw the graph. Graph is x squared, that means up opening. One intercept is minus 2, so one intercept is minus 2, another intercept is plus 6. So suppose plus 6, and it does not matter where your other points are, because somehow see how you can decide very quickly for your answer. You know that the graph will be up opening. One intercept is here, another intercept is here. So our graph must be somewhere here. Where it is we do not know, but somewhere here our graph has to be, because from minus 2 to 6 our graph has to be. Now the question is where it is less than or equal to 0, and of course less than or equal to 0 is this side again. Okay, so this is how we can actually quickly decide about what will be our solution. What will be our solution? Okay, so from minus 2 to plus 6. And if you are interested, you can give the y-intercept here, which is minus 12, and you already know how to find out vertex, that means this value. If you are interested, we can actually find a lot of things. But our main question, what is the question? What question we are trying to solve? We are trying to solve is that inequality. From minus 2 to plus 6, we have our solution. Question is, where is this solution? Where the graph is less than 0, where the graph is less than or equal to 0. So the solution is this. So we just need these two value basically. We just need need these two value here. And of course, the other thing is the decision making process. You just analyze it in your just think about it, and then you just develop the decision. My point is, drawing the full graph is just a waste of time, but if you are interested, you can draw it. Okay, so this one is little bit one step ahead kind of graph. So you see this question is like 2x squared is less than x plus 10. 2x squared is less than x plus 10. So where is the solution we are trying to find out? So let's look at this. You will notice that if we 2x squared, then if we bring this to this side, bring x plus 10 to this side, then basically our equation looks like this. 2x squared 2x squared is 2x squared minus x minus 10 is less than 0. So our equation basically looks like some equation that we solved in our previous slide, like that. Okay, and simply then we can just solve, find out the y-intercept, find out the x-intercept by considering the function equals to 0. Then we can factor it. There is two factor here. So one answer is 5 by 2, another answer is minus 2. And when we have them, one is minus 2, so say minus 2 is here, 5 by 2 means 2.5. So suppose 2.5 is here, and we can see that the graph is 2x squared, which is positive. Again, positive means up opening parabola. So see, again our graph will be something like this, So our solution has to be less than, so 2x squared minus x minus 10 is less than. So less than has to be this side because it is below x line. Below x line is less. So from which value to which value? Value has to be from minus 2 to 5 by 2. So this is the solution from minus 2 to 5 by 2. Now notice that our inequality is strict. That means only less than sign, not equal to given. That means our solution will be only first bracket. So minus 2 and 5 by 2. That's the solution. So this is how we know the solution. So if the algebraic thing is given, this is how you can decide. And if this is the graph actually, if the graph is given, then actually this is like in a second you can get the answer. Suppose question is less than 0. Oh, less than 0 is here. Less than 0 is here. So from minus 2 to 5 by 2 answer. Minus 2 to 5 by 2. This is the less than 0 part. And if the question is greater than 0, you may thinking greater than 0, what is the answer? So greater than 0 will be from minus infinity up to minus 2, from minus infinity to minus 2. This is the greater than 0 part. And of course from 5 by 2 to plus infinity, because this is going forever. So 5 by 2, from 5 by 2 up to plus infinity, that will be the greater than 0. Why? How do we know that? Because this part of the graph is less than 0, that means everything else is greater than 0. This is another way to decide. Okay, that means everything else is greater than 0. Just simply suppose where is Faisal now? I am in Chittagong. That means if I am in Chittagong, that means I am not anywhere else in the world. I am in Chittagong. So if you know where I am, then you can actually answer where I am not. That part also you can decide easily. So if we can decide that this part is less, so that means that everything else is greater. We actually have the solution of this math in alternative method also. There is another method for solving this math. So let's look at that. Alternative method is this one. Same question, 2x square is less than x plus 10. Now in this alternative method we can actually, you can see that our graph is different. What we have done here is, we considered two different thing here. This part one time and this part another time. We consider two functions here. One is y equals to 2x squared. Another one is x plus 10, y equals to x plus 10. So we consider two functions. This is another method. Just we can solve the math this way also. Then what we have done here is, if you want to, this is, of course, this is just taking time, a little bit extra time. Y equals to 2x squared graph is this one. Y equals to x plus 10 graph is this one, and they will intersect at some point. This point and this point, they are intersecting here. Now question is what? Question is, where is 2x square is less than x plus 10? We are now thinking it separately. In other words, we can say that where is this function, that means our parabola is smaller than this line. And you will notice that our parabola is smaller in this part. Parabola is less, parabola is downside in this part of the graph. Parabola is down. So parabola is smaller. Parabola is smaller. 2x square. See, 2x square is less. This is the less than sign. Less than x plus 10. That means x plus 10 is this line. Down the line, down this line is less. Down this line is less. So what will be the answer? And you will see that, interestingly, answer is same. Answer is from -2 up to 5/2. From this point, which is -2, 8, and this point. Within this space, our parabola is below the line. Parabola is below the line. And question is where it is below. Less than means down, smaller. So our answer is -2, from -2 to 5/2. From -2 to 5/2. And how do we get this -2 to 5/2? They are the intersection point between the in the graph, when the graph is given. And if the graph is not given, then how do we know? If the graph is not given, then we have to again similarly solve it. Basically, we have to do the same thing again. 2x squared. We have to consider 2x squared equals to x plus 10. Then bring it to this side and solve it. You will see one solution is -2, another solution is 5/2. Then how do you know that another value is 8? You can put -2 in any of the function. If you put -2 here, you see answer is 8. -2 whole square means what? 4. 4 into 2 means 8. So if you put -2 in any of the function, you will get this 8. And if you put 5/2 in any of the function, you will get 25 divided by 2. So this is how we get the other value. And how do we get, once again I repeat, how do we get -2 and 5/2, which is most important thing in this kind of maths? That is, we consider just like our previous page, we consider this twice x square and then bring it to this side, consider it equal to 0, and because we are trying to find out the solution, that's why we are considering it equal to 0. And then actually we can get this two value, -2 and 5/2. So our answer is, still the answer is same. Still answer is from -2, 5/2. But this way of solving actually gives us another interesting thing, which is coming up in the next page. This one. Suppose our function is given like this now. This is the function. You try to solve this. Let me explain the function math so that you can try. This is taken from the book. So suppose our blue graph is called fx, y equal to fx, blue graph, and red line, this is called gx. So the name of this line is called gx, the name of this line is called fx. Parabola is fx and red color line is gx. Our question is, where it is where fx is less than gx, this is question A, and question B is where fx is greater or equal to gx. So you try to solve it, then I will tell the solution, of course. You try to solve it first. Give a try. So yeah, when you are finished, it just if you have paused the video, you have to come back. Yeah. Um, so let's try to solve fx is where fx is less than gx. Fx is less than gx, and or where fx is greater or equal to gx. That part also we can do. Let's do this part first. Let's do this part first. We can do any part. Fx is greater or equal to gx. Fx is this graph, blue, and see this part here is above the line. This part here is above the line up to this point. So that means from -3 up until 1, from -3 to 1, our fx function is greater than gx function, because gx above, this is above gx line. Okay, this is above gx line. This part here is above the gx line. So the solution of B number will be from -3, and you can see that this is not a strict inequality, so answer will be from -3 to 1. This will be our solution. Now this a number question, if we now look at this, which is actually opposite, this is greater and this is less. Now we can actually decide it using our counter logic. If this part from -3 to 1 is greater, that means the other part is less. That means the other part means this side, and from this extra, this side is less. How do we write the answer? How do we write the answer? This question is, look at this, fx is less than gx. That means gx is now more. So you see, this line is bigger, this line value is more, or this line value is more. And definitely you will say that, sir, this line value is more. Value means why? Because you see, after this point, this line started going up. That means value is increasing, and this line value is going down. That means the value is decreasing. Now here, both of the line is going down, but you see who is going more down. This line is going more down, and this line is up. That means from -infinity to -3, this is a strict inequality, so we have to give the first bracket. From -infinity to -3, our fx is less. That means our parabola is less, our gx is more. And from 1, this is 1, remember only always x value only. From 1 to plus infinity, our gx is greater. So this is how this is the solution of this kind of math. We have to just look at the graph, and we have to see, okay, which thing is above and which thing is below the condition. Okay, so suppose, and the very useful thing is to spot the line and just look at, okay, this is the line from here to here, they intersect. Which is above the line, which part is below the line? And of course you can see this part is above the line. From -3 to 1, this part is above the line. This part of the curve, this part of the parabola is above the line. That means the other part is below the line. This way also you can decide, or you can just we can just look at the graph and do it step by step. That also works. In the next slide, we have 2 more maths which we will try to practice in class. So you can do it in advance also if you want, and we will try to practice them in class, and your homework or practice homeworks are this. These are not You do not have to submit as usual. These are just practice. Okay, similar kind of maths, and there are actually some maths related to algebra also, since we solved some algebra in the one number, two number, two, three number slides, etc. If you face problem, of course, we can discuss them during the class also. So thank you everyone. Thank you very much. And that's the end of this today's slide. Have a good day everyone. Bye bye.